Hi guys, Dave here, and the implication of this question, when aren't heat pumps the cheapest form of heat, is that there must be a time when they may be, or when they are the cheapest form of heat. So we're going to look at what's different about heat pumps now to make them the least expensive, the most parsimonious way you can heat your home or your she shed or your man cave. You're maybe looking at building, mother-in-law house, pool house, cabin, something either on or off your compound. Maybe you just want to get one 12,000 BTU mini split heat pump, and because it may save you energy. And so we're going to do a little analysis to see if it potentially will here. And we're going to do it in all places of Peoria, Illinois. Why Peoria? Well, there was a saying that, oh, if it plays in Peoria, it's going to play anywhere. So Crest would take their toothpaste from Cincinnati and they'd put it on the shelves in Peoria. And, oh, this new variation sells great. Let's expand it nationally, or maybe not so much. So Peoria is in the northern region of Region 4, DOE Region 4. A lot of people have similar needs, not too far away from Chicago. If you're in Upper Peninsula, Michigan, or Duluth, your needs are a little bit different. Your analysis, similar analysis, but different results potentially. But we're doing it here, which is going to be a wide swath, I think, of the needs for a lot of you watching this. Okay, maybe you're even a little bit warmer region than Peoria. But so if you look at the graph on the left, that shows the time that you actually need heat, and about 76% of the time you need heat, it's above 29 degrees Fahrenheit. Okay. And you'll see, oh, it's only 6% of the time that's below 10 degrees. The problem with this, it's not your actual burn time of when your unit is running. So the one on the right shows the actual time when the unit is running, and that looks a little bit dicier for the temperatures above 29 degrees. That now shoots down only 52% of the time. And meanwhile, the time when it's super cold is 16.1% of the time. And this region right here, this is the area where heat pumps now can address when they didn't used to be addressed. Heat pumps used to go down to like 35, 38 degrees, pretty worthless, okay? And attacking this big swath over here. And the problem is that just the technology wasn't there. Now there's something called inverter compressor, which gets these units down to around 14 degrees. The new R32 refrigerant gets them down about 5 degrees. And then some, like ours, the one we're looking at here, has something called enhanced vapor injection, allowing heating even when the outdoor temperature is minus 22 degrees Fahrenheit, okay? And that's our unit's not so much of an outlier. You can get ours, you get somebody else's that has, ours that has a HSPF of 10.8, so that's a higher HSPF than the old ones, and it's based on the fact that it can do heating at these colder temperatures. And so here are the 4 types of heat. Electric baseboard heat, if you have that, it's the good news about electric baseboard heat or portable electric heater, it's 100% efficient. The bad news, it's like in Peoria here, you're paying over 18 cents a kilowatt hour. So if you're getting 18 cents, if it's costing you 18 some cents to produce 1 kilowatt hour of heat, you'll see that's not your best option. It's even worse than the second worst here, which is home heating oil. Home heating oil, super expensive as well. If you have one of these two, if you can get a heat pump, get a heat pump. I'm assuming if you have these two, you can't get natural gas for cheap. There's no gas hookup, but get natural gas. If you don't already have natural gas and it's cheap to potentially get yourself some natural gas, or get the heat pump based on the rest of the story here. So all 3 of these, electric baseboard heating, home heating oil, and natural gas, all do the same thing. In fact, they burn energy. So home heating oil burns 85% efficient, maybe. Natural gas furnace, maybe 95% efficient. So, pretty efficient, but compared to what happens with heat pumps, they work differently than burning something. Instead of burning something, they carry the heat from the outside to the inside. So it's analogous like the Costco gas truck. It's getting 5 miles a gallon, but it's carrying 10,000 gallons of fuel, right? And so at the warmer temperatures, it's actually costs like pennies to produce 1 kilowatt hour of heat. So, above 40 degrees, no brainer to use a heat pump. We'll use this orange line here is without solar assist. The blue line, ours actually unplugs solar panels into it. That makes the math a little bit different. We're assuming that for 4 hours a day in Peoria, and the assumption is based on NOAA data and WeatherSpark data. If you haven't ever checked out weatherspark.com, look at it. It's amazing data based on how much how long your heating season is, what your peak temperatures are, what your humidity levels look like through the year, how much precipitation. It's fun stuff to look at. But so Peoria gets around 4 hours, statistically speaking, of sun a day. So we're using those 4 hours, plug in solar panels to run the unit for free during, or potentially a good chunk of those 4 hours for free using solar energy. Okay, so the orange line here is just a standard super efficient heat pump, and the blue line here is with solar assist. And so yes, you're carrying the heat from the outside to the inside. It gets tougher the colder the temperature is, right? So like the heat pumps, like in the early 2000s, you couldn't get that outdoor coil colder than like 30, 35 degrees. So how do you carry the heat from the outside when the coil is only 35 degrees? It can't absorb it. Ours, the coil gets down past minus 22 degrees, so it's even colder. It absorbs the heat and still able to carry some heat to the inside. Bad news, yes, the heat pumps to carry that heat to the inside. Now the Costco truck is like driving up a steep hill and it's getting 2 miles the gallon. The heat pumps now at these colder temperatures need a lot more electricity to run, but in the grand scheme of things, if you look at it graphically for what you're actually spending, so you can see sort of the cutoff point here. So our unit without any solar assist, about 28 degrees. After that, this graph of the natural gas becomes less expensive to run natural gas or heat with natural gas than with a heat pump. So if you're one who goes to Florida for the winter, you're from Michigan and you go to Florida for January, February, March or whatever, you're not going to have much of this region, right? And so heat pump for sure is going to be cheapest heat for you. If you're instead putting this in a ski cabin where you only go up there on the weekends and it's always 6 degrees out, if you got natural gas in that scenario, keep it, because that's probably going to be your best bet for when it's super cold. But so since we're looking at this over the whole winter, this is what it looks like for the whole winter. And so, in fact, and so the one on the left is our HS12 heat pump without any solar panels hooked up to it. If you add up, and so the ones on the left are at warmer temperatures. The right here, you can see that the natural gas takes a lot less in that period of time in the winter than our standard non-solar assisted HS12 unit. And so, but if you add them all up, it ended up being that the natural gas was $187 for the 500 square foot, and the HS12 superheat heat pump was only $183 for that period. You can say, hey, Dave, I'm not heating my whole house for $183. I'm paying $1,000 winter. Well, that's probably because you maybe have a 2,000 square foot house, right? Because the analysis here is only based on 500 square foot. And why 500 square foot? Because normally, rule of thumb, 12,000 BTU unit, which we're using in the analysis here, will heat and cool about 500 square foot. So this is the cost over the course of the winter and we didn't, by the way, you're not seeing home heating oil or electric baseboard heating in this analysis anymore. Get rid of those if you can. But anyway, hopefully this helps you if you're spending most of your time in the colder part of the winter inside. Natural gas still going to be your best bet, and probably the analysis will look a little bit different. But this is if you have the unit running all winter long. Heat pumps, today's heat pumps, you can get one. Yeah, you get one more efficient than ours. Ours is 10.8, works well for our price point. You can find some that are even more efficient than 10.8 HSPF. If you're in more northern region 5, you probably want to look into that. But for a good swath of America, I think this is here based on this data. It's cheaper to run a heat pump than it is natural gas. So put in your questions from all this in the questions here. We are Airspool. Subscribe to the Airspool channel if you want to talk about solar, if you want to talk about air conditioning, if you want to talk about heating, if you want to talk about solar assisted heating and air conditioning. And thanks for your time.